So hello everyone, my name is Benji. I work in product at Molecule. It was about a year ago, I was at a different job. I was working for a biotech venture fund, and I was debating whether to jump in this space. And looking back at the past year, it's been absolutely incredible to join the Molecule team and jump into what is this incredible movement. I'm so glad I did, and excited to talk to you guys about what we've been up to for the past year. So this talk is going to be jump around quite a bit, so expect it to cover a bunch of different varied topics, and I apologize for that in advance. But the goal is to make it as linear as possible in terms of the claims that are made. So each of these points here are meant to build off of the next, ultimately getting to point number 6, which is that DeSci can create scientific value without jeopardizing IP. That's like the main thesis, and all of these previous claims are meant to build off one another to bolster that claim. So number 1 is that access to medicines is a compelling value proposition. So the first time I ever came into contact with the DeSci space was when Chris Leiter, who you just heard from, was at a friendly venture fund, and he sent me Molecule's deck, and the first thing I did was go to their website, and this is what I read: "The future of medicine belongs to everyone." And it hit me in the face, and it was like very much love at first sight, because I hadn't been in venture long. I'd been there for maybe 2 months, but it was enough time to realize how access to medicines and being able to own a piece of a medicine, how difficult that process is. When I joined venture, this is what I was expecting. I was expecting to sit on a panel with the other people in my fund, and we were just going to get so many opportunities thrown at us that was going to be how all of our time was spent. But that is not how our time was spent. I actually took a video of exactly what we spent day to day, and here it is. Here's what it looks like. Basically, talking to absolutely anyone you can who may know somebody who has access to a funding opportunity in biotech. Most of biotech also happens in stealth, so there's an incentive to keep everything super close to your chest. You don't even know that these companies are being started, let alone have the opportunity to fund them yourself. So this idea of having access to compelling value propositions was I'm the target market. So yeah, kind of like I said, it really favors these master networkers, not the master capital allocators or scientists. It really is those who work at big brand name venture funds who are really able to get access to the best investment opportunities in biotech. And that kind of bothered me. It really did. Because this is really what you want people spending their time doing, which is analyzing data, analyzing papers, patents, business models, commercial feasibility, rather than networking. That is the best use of human capital toward biotech capital allocation. It's not looking for opportunities, right? And so ideally, this is what even early stage biotech funding would look like. Of course, you have the hedge funds and the D.E. Shaws of the world that are doing quantitative analysis on biotech investment opportunities, but that's because these companies are public and they release a lot of data. Ideally, you would still have this even at the earliest stages of scientific research funding at the basic research level. And so I think this is kind of like the main point here, which is that increased access to biotech funding will maximize the brain power that is predicting value relative to searching for prediction substrates. And that's ideally kind of the shift that we want. We want these opportunities to be so abundant that everyone is just focusing on how to diligence them rather than sourcing. So number 2 is IP tokens create broader access to medicines. So I assume most of the people here are familiar with Molecule's tech stack and the IP NFT. If not, I can briefly go over that. But basically, the idea is to bridge legal world rights for intellectual property on-chain via NFTs. And so these IP tokens are basically the next iteration of that, where rather than have it be a single non-fungible token held by a single entity, you can now democratize ownership of that. And so before I go into all of this, would like to give a huge shout out to the Molecule legal team who came up with everything I'm about to talk about. Jesse and Chris are right here. They're absolute geniuses. And what they designed in this token primitive is called an IP pool. And so it didn't make sense to me, but I'm here to kind of be the bridge between the layman and the legal team. But an IP pool is basically an entity that holds IP. Actually, wait, I wrote down the definition. I don't want to get it wrong. I guess I still don't know. It is a fancy way of saying a bunch of people who do research and development together and contribute IP to an entity and collectively govern how that IP is used and who can use it. So it can take multiple forms. It can take a, Bell Labs, for example, IP pool. Any corporation, IP pool. Basically, everyone within this entity is incentivized to collaborate with each other because they all collectively share whatever IP and rights come out of it and whom those rights can be licensed to. So we designed these IP tokens as ERC20 tokens that are fungible governance tokens. And so the question is, if our goal is to democratize access to medicines, why don't we just democratize ownership directly? And it's because if you give ownership and title of IP to a bunch of people, it devolves into chaos because anyone can do licenses without telling the other owners. So what we realized, and the cleanest way of doing this is actually by democratizing the governance of those singular IP rights. And that's done via this IP pool. So another value proposition of these IPTs is that the community can take part in the research itself and its governance. So it's still to be determined whether this is an effective way of de-risking biotech IP, but we do think this is a compelling value proposition. If you want to have a say in how the research gets developed, which CRO is used, which personnel are hired or fired, it's important that the community feels engaged with the projects themselves, and this is their mechanism to do so. And third, and probably most importantly, is the ability to decide who the IP can be licensed to and on what terms, and how royalties can be distributed. So we got a ton of legal advice when we were developing these primitives and found out that actually hard coding royalties of IP into the token might be a legal risk. And so because of that, what we did is rather than hard code it in, we gave the governance right to govern how those royalties are distributed. So essentially, those rights carry with the token without the token itself carrying those royalty rights, and you can read between the lines of why that's important. So this IP NFT was originally funded by VitaDAO. It funds Viktor Korolchuk, who's researching autophagy inhibitors at the University of Newcastle. And they needed more funding to continue their awesome research. And so we used this primitive as a beachhead with this project. And so, yeah, a few months ago now, basically we took the IP NFT, we tokenized it into I think a million tokens, and we sold a portion of those to the VitaDAO community. And what we basically de-risked here is that there actually is appetite and demand for these governance tokens to basically govern these individual projects. And so we had a crowd sale. It was oversubscribed by 1,700%. One of the really cool outcomes of this was we got the University of Newcastle involved. They developed a wallet, and we sent them tokens, a university tech transfer office. Really cool. And the researcher also. So this researcher who's not a Web3 native person by any means, he's an academically trained scientist, has already voted on a few snapshot governance proposals. So we can onboard scientists into Web3. It just takes a little bit of work and a little bit of an incentive, and people will do it. And Dr. Korolchuk is super excited about the community that's being created around his project. So point number 3 is with IPTs, we can incentivize scientific contributions. That's an important point to de-risking the fact that we can create value with DeSci. So you heard from Nicholas. Nicholas, he actually mentioned this exact project. We contracted LabDAO to do an analysis on the data that had been generated by the Korolchuk project, and we paid them with IP tokens as compensation. And so, yeah, just very briefly, it can be done. This was the first example of it. But it is an important point that if we can create tokens out of thin air and we can incentivize people to do productive science with them, then we've won, right? But it is really about bringing in more and more of these scientists into this ecosystem and convincing them that these tokens are valuable. But we've done it once, and we'll do it again. So the question is how do we decentralize that process? We did it with LabDAO, but it was basically like Nicholas and on our studio analyzing the data. He signed NDA. But is there a world in which we can potentially decentralize this process and leverage the hive mind that exists from having multiple scientists work on a project? And so the only way I could think about how to explain this is mathematically. So what is the expected value of research? as you mess with the number of researchers, increase it up or down. And so I came up with the super basic calculation of just how I think about it, but it's basically the expected value is the revenue associated with a project, finding a drug and its market size and the number of patients and how many doses. Like that's kind of a fixed number, whether you find a drug for a certain disease or not. But what's not fixed is the number of researchers, which is NR, the probability of success for a specific researcher, and then the cost of that researcher. So the question here is, can we reduce the cost that we pay researchers and increase the number so that we can increase the expected value? Because if we can increase the number, then what we can do is increase the probability that this revenue will be realized. But yeah, I mean, this basically what you need to have happen is ensure that the revenue times the number of researchers times the probability that the researcher is successful is greater than the cost. And an important piece of the cost of increasing the number of researchers is the risk that the data gets leaked. So the more people you have that are seeing the data, the greater the chance that the IP gets leaked. So another kind of hidden cost there, especially in biotech where IP is everything. Number 4 is that there's an illiquid market for computational biology. So right here, this is a graph of the cost of living in different countries and the PhD stipend in that respective country. So the yellow lines are the cost of living, and the red line is the stipend. So you can see, especially on the right, is that the stipend that you get as a PhD researcher is lower than the cost of living. You're basically starving, right? You have to be supported by somebody because off of your stipend, you can't afford to live in those countries. And so what you have is a bunch of people who are highly educated, extreme experts at a specific domain, and they can't even live paycheck to paycheck. And another important thing is when you sign a contract to be a PhD student, oftentimes you can't do contract work. So you can't consult for certain companies. You have to get that approved by the department, and I'm sure that gets caught up in bureaucracy quite a bit. But what you can do is participate in bounties. So this is potentially an opportunity for us. I think one important data point here is that with the trading fees that have come from VitaFast, we can pay for a graduate student from January to March based off of current stipends that people receive. It's just interesting. Like the speculation alone can pay for months of PhD student time. So another important piece here, so that was meant to address the supply side. Now let's look at the demand side. So important here that basically this is how things currently operate. You have a few data scientists, they're in the walled garden of this biotech company, and there's all these potential data scientists that could extract all this potential value from the data inside, but they're never given access. So basically what traditional biotech has decided is to protect their IP in the name of the cost of leakage, basically. So it's, yeah, basically the supply is high and the demand is low in biotech, and hence why it's an illiquid market. So the best part, wait, this slide's out of place, I apologize. So another important piece here is that decentralized communities can already solve very complex biological challenges. So I don't know if you guys are familiar with Kaggle. Kaggle is like a decentralized data science platform. People can just show up and get access to data and do really cool analysis on important data science problems that people are trying to solve. And one of those problems was Recursion. Recursion is a very famous AI and drug discovery biotech company, and they put out a data set, and you can basically read their reviews. They're so impressed by the community. So the important piece here is that the data that's shared is non-confidential, right? Because of course you can't release the confidential data and trust thousands of data scientists. But the important part is with just the data set, they were able to attract all of these really cool computational biologists who were able to extract a ton of value from the project. But the question is, if this is so great, there's so much money in pharma, why aren't other people doing this already? And that gets to the next most important claim here, which is that drug discovery data can be shared safely to low trust individuals, and this is an opportunity being massively missed by the existing pharma community. So most of biotech and pharma treat data leakage risk as basically completely binary, right? Either I get NDAs with absolutely everybody and then I share them the sensitive data, or Yeah, that's it. That's actually the only option. Like, they don't get access, or they get access to the sensitive data and they sign NDA, and if there's anything wrong, I have legal recourse. I think what we're promoting here with DeSci is that you can share non-confidential data with as many data scientists as possible, so long as you preserve the IP, and so long as you preserve some of the information from the sensitive data itself. So, yeah, our whole thesis here is that there is kind of like this local maximum that biotech and pharma are in, and that they can achieve a global maximum if they are willing to share the data with more people. I'm not saying open source the data. I'll get into a little bit more of what I mean more specifically. So we have a challenge with the current like VitaFast, like Victor Korolchuk's project right now, which is to be able to predict the outcomes of the actual assays that are being run. So our goal is to optimize and find the best chemical structure that induces autophagy. That's the ultimate goal, right? And we have these different assays that we're using to test, to see, to predict basically in a human which will be the best chemical matter that's safe and effective to increase autophagy. And we've already generated a ton of data, and so the goal is to train models to be able to predict data on compounds that we didn't test. And so what you would run in like a, any drug discovery project is called QSAR, which is quantitative structure activity relationship. And so what this basically is it's looking at certain parts of the compound and saying, oh, these are helpful, these help induce autophagy, and looking at the blue parts of the compound and saying, actually, those don't really help, we want to get rid of those. So to be able to make those associations is super important. And so the question is, how are you able to do this without the compound's identity? And the answer is in fingerprinting. So you are able to preserve certain pieces of information about a compound without giving away the IP, which is the compound structure. Right? So this is the important piece here, is that you can actually democratize and make certain data sets go viral because you're not giving away any of the IP. You're preserving information about it. And I'm sorry, I know this is kind of like a complex piece here, but it's arguably like the most important piece of this entire talk, which is that none of the lawyers are data scientists at pharma companies, so they don't get this point. But as soon as somebody does and takes advantage of this, then they can have the entire world's army of data scientists mining their data because there's no risk. There's no risk of going from one of these fingerprints back to the drug. And so if you can democratize that data and let anyone come and perform analysis on it, then you basically get low risk computational biology on all of the drug discovery data that you're generating. And this is so unbelievably powerful. And all of the tools are there. It honestly is just going to require someone to do it. And so here we are trying to do it. And so, yeah, point number 6, DeSci can create scientific value without jeopardizing our IP. And so what you're getting here is a sneak peek of VitaFast Development Proposal 3, Fast and Spurious. And so here are the rules. It's going to be a hackathon. We are going to release all of the experimental data created from the Korolchuk project, but we're not going to release the compound identities themselves, obviously. That is the IP. So we're going to release the fingerprints. So there's multiple fingerprinting methods. Some of them are spatial, some of them are semantic. We don't really care. We will create all of the fingerprints that are useful and predictive of the actual like assay data itself. And so, yeah, the goal of this is to help us select which compounds to advance down the pipeline. I mean, that ultimately is the decision making you have to make in biotech, is which compounds do we advance? And we want as many people and hive mind trying to help us make that decision. So we're going to create a purse of 5K in USDC and 10K in VitaFast. The way we're going to decide who to compensate is by training a meta model, which is like a model of models. So we're going to take all of the input models, we're going to take a meta model, and then we're going to see how much information does each of the submissions add to the final model itself. And what that'll do is allow us to not have to dox everyone and require them to KYC, because you don't want like to be at the whim of like Sybil attacks here. You want just anyone to be able to submit as many as they want, and anyone who adds information to the final prediction, we can compensate. So we're going to leave submissions open for all of October. Definitely stay tuned for more updates on this, but really freaking excited about this. And this will kind of give us a list of researchers who we can then bring into more of an inner circle and give access to the full data set to. And definitely to stay as invested in advancing the project as possible. But yeah, anyone is eligible, and yeah, with that, if you'd like to join the Discord, that's the QR code. And yeah, then that's a Uniswap link to buy the token. Thank you.